Hello friends, you are watching ICSE Mathematics and today we will learn chapter number 14, Equation of a Straight Line of class 10 ICSE Mathematics. Before we proceed further, please I would like to remind you that please like and subscribe my channel ICSE Mathematics. Okay, now let us begin with the term angle of inclination. Angle of inclination. Okay, we will draw a diagram for this x and y coordinate axis and a line AB. Okay, so angle of, you look at this figure. Okay, a line AB forms an angle of theta with the positive direction of x-axis. Positive direction means the direction considered anti-clockwise. Yes or no? Always anti-clockwise direction we will consider to be the positive direction, and the clockwise direction we will consider to be the negative direction. Clear? So angle of inclination is the angle theta formed by line AB with the positive direction of x-axis. Clear? So we will write down over here that angle of inclination theta is the angle formed by line AB with the positive direction of x-axis. Clear? Okay, now few things we should remember that angle of inclination of any line or angle of inclination of x-axis is 0. Okay, few points we will remember that angle of inclination of x-axis is 0. Number 2, angle of inclination of any line which is parallel to x-axis is also 0. So if we have any other line which is parallel to x-axis, its angle of inclination will also be 0. Yes or no? Similarly, third point to remember is angle of inclination of a line which is parallel to or angle of inclination of y-axis. Now y-axis forms an angle 90 degree with the positive direction of x-axis, therefore angle of inclination of y-axis is 90 degree. So angle of inclination of y-axis is 90 degree, and any other line which is parallel to y-axis will also form an angle of 90 degree. Yes or no, with the x-axis, and therefore the angle of inclination of that line, which line, parallel to y-axis, will also be 90 degree. So the fourth point is angle of inclination of a line parallel to y-axis is also 90 degree. Clear? So you have understood what is an angle of inclination. If any line forms an angle theta with the positive direction of x-axis, that angle theta is called the angle of inclination. Clear? Okay, so and positive direction means anti-clockwise direction, and negative direction means it is the clockwise direction. Okay, again the 4 points we will remember that angle of inclination of x-axis is 0. Then angle of inclination of any line which is parallel to x-axis is also 0. Angle of inclination of y-axis is 90 degree, and angle of inclination of any line which is parallel to y-axis is also 90 degree. Clear? Okay, now okay. Now when we draw any line which is parallel to x-axis, okay, now onwards we will call such a line to be a horizontal line. Clear? So any line which is parallel to x-axis is called the horizontal line, and any line which is parallel to y-axis is called the vertical line, and a line which is neither parallel nor perpendicular to x-axis is called an oblique line. So here suppose we have line AB. Line AB is an oblique line. Clear? While this line, say line L and another line M. Okay. So line L is parallel to x-axis, therefore line L is a horizontal line. M is perpendicular to x-axis, therefore line M is a vertical line, and line AB is neither parallel nor perpendicular to x-axis, therefore AB is an example of an oblique line. Okay, now let us come to the next term, that is the slope or the gradient of a line. Slope or gradient of a line. Okay, what is the slope or the gradient? So for that, once again we are going to draw a diagram. X, Y, and say this is line AB. Okay, and angle of inclination is theta. So if theta is the angle of inclination of line AB, then tan theta is called the slope of line AB. Clear? If theta is angle of inclination, then tan theta, that is perpendicular upon base for this triangle. Yes or no? Will give you the slope of line AB. Clear? It is denoted by symbol M. It is denoted by M, and therefore slope of line AB denoted by M is equal to tan theta. So if you are given the angle of inclination, for example, suppose 30 degree, then tan 30 degree is equal to 1 upon root 3. So value of slope M will be 1 upon root 3. If theta is 60 degree, then M will be root 3, because tan 60, the value of tan 60 is root 3. Clear? Okay, now let us discuss the slope of the various lines. For example, slope of x-axis, slope of y-axis, slope of any line which is parallel to x-axis, and slope of a line which is parallel to y-axis. So we will discuss first the slope of a line which is a slope of a line of x-axis. Now obviously x-axis is a horizontal line. Okay, so there is no angle of inclination formed, clear, because no rotation we see or no angle theta we see, and therefore slope of a line x is always 0, clear, because value of theta is 0 and therefore tan 0 will be equal to 0 only. So we will make this notes over here. Number 1, that slope of x-axis is 0. Again, slope of a line which is parallel to x-axis is again 0. Then number 3, slope of a line or slope of y-axis, slope of y-axis is undefined. Why? Because tan 90 is undefined, because the angle of inclination of y-axis is 90 degree and tan 90 is undefined, therefore slope of y-axis is undefined. Similarly, slope of a line parallel to y-axis is undefined. Clear? So we will remember these 4 steps. Number 1, slope of x-axis is 0. Number 2, slope of a line which is parallel to x-axis is also 0. Number 3, slope of y-axis is undefined. And number 4, slope of any line which is parallel to y-axis is also undefined. Clear? Okay, now let us derive a formula to calculate the slope of a line. For that we will draw a diagram. Okay, let us consider a line and we will take 2 points A and B on the line whose coordinates are, say L is the line, yes or no, and A x1 y1 and B x2 y2 are any 2 points on the line L. Okay, the angle of inclination of line L with x-axis is theta. We will draw 2 perpendiculars M and N, yes or no, such that distance OM will be x coordinate, that is x1, and distance ON will be x2, so MN will be x2 minus x1. Now if we draw one more perpendicular, say A, B and C, here AC perpendicular to BN, and then AMNC is a rectangle and therefore MN will be equal to AC. So MN is x2 minus x1, therefore AC will also be x2 minus x1. Now look at the length AM. Perpendicular length is given by the y coordinate, so y1. Now since AM is y1, the opposite side of rectangle CN will also be y1. Yes or no? Again, perpendicular line BN will be y2. Clear? And therefore BC will be y2 minus y1. So BC will be y2 minus y. Clear? So we got the two lengths AC and BC. Further, this angle, okay, angle of inclination of line L with x-axis and this angle BAC are corresponding angle, therefore this angle will also be theta. Now for triangle ACB, we can find out the value of tan theta, and tan theta is equal to slope of line L. Clear? So let theta be the angle of inclination of line L. Yes or no? With positive direction, or theta be the angle of inclination of line L. Obviously it is with x-axis only, we know that. Okay, and A x1 comma y1 and B x2 comma y2 are 2 points on line L. Okay, we will draw AM perpendicular to AM and BN perpendicular to x-axis, yes or no, and we will draw again AC perpendicular to BN. Clear? Now AM and C is a rectangle, yes or no? Okay, let us write down length OM. OM is x1, okay, ON is x2, and therefore MN will be ON minus OM, and therefore MN is x2 minus x1. Okay, similarly AM is equal to CN is equals to y1. AM and CN are equal because opposite sides of rectangle, yes or no, and BN is equals to y2, and therefore BC is equal to BN minus CN is equal to y2 minus y1. Okay, again angle BAC will be equal to theta, yes or no, because these two angles are corresponding angles. Now in triangle ACB, tan theta is equal to BC upon AC, and therefore okay, now MN and AC are equal, so here in the next step we can write down AC is equal to x2 minus x1. Clear? Because MN and AC are equal only. Okay, so tan theta is equal to BC is y2 minus y1 and AC is x2 minus x1, and we know that tan theta is denoted by m. Clear? So this is the formula to calculate the slope of a line. Okay, whose points, 2 points are given, or A and B with coordinates x1 y1 and x2 y2 are given. So y2 minus y1 upon x2 minus x1 is equal to m is equal to tan theta, which is equal to slope of the line. Clear? So whenever you are given the coordinates of any 2 points on the line, you can calculate the slope of a line using this formula y2 minus y1 upon x2 minus x1. Clear? So now let us discuss the slope of certain lines. For example, slope of x-axis, slope of y-axis. Yes or no? Similarly, slope of a line which is parallel to x-axis and slope of a line which is parallel to y-axis. Okay, now we will make note over here. Number 1, that slope of I think we have discussed this earlier, slope of x and y axis, yes or no? On that slope of x axis and any line which is parallel to x axis is 0, while slope of a y axis and any line which is parallel to y axis is undefined. Clear? So that we have discussed. So we have completed all the discussion of slope. Okay, one more thing, from the slopes we can calculate, we can find out whether the given points are collinear or not with the help of the slope. So how? Okay, that is, we will call it a condition of collinearity. So condition of collinearity of points A, B and C. Okay, so what is the condition? 3 points A, B and C are collinear Okay, 3 points A, B, C are collinear if slope of AB is equal to slope of BC or AC, anyway you can take. Yes or no? Two different points we should take. Slope of AB is equal to slope of BC. Then we can say that the 3 points ABC are collinear. Clear? Okay, so remember this condition of collinearity. Now let us understand the terms x-intercept and y-intercept. Okay, x-intercept. Let us draw x and y axis. O is the origin. AB is a line such that it intersects x-axis in point A with coordinates A, 0 and point B with coordinates 0, B. Obviously length OA is called the x-intercept, yes or no? From the origin to point A, distance OA is called the x-intercept. Similarly, length OB is called the y-intercept, which is B in this case. Clear? So what is x-intercept? It is the intercept made by the line on x-axis. And what is y-intercept? It is the intercept made by a line on y-axis. Clear? So x-intercept, it is the intercept made by a line on x-axis. Okay, so in this case OA is equals to A, clear? And y-intercept, what is y-intercept? So it is the intercept made by a line on y-axis. Okay, so in this case OB is a y-intercept is equals to B. Yes or no? This is OA is equals to A is the x-intercept. Clear? So, okay, on the right hand side we consider the value of the intercept to be positive, and on the left hand side we will take the value of the intercept to be negative. Similarly, above x-axis positive value of y-intercept, and below x-axis we will take the negative value of y-intercept. Clear? Okay, now let us see the different forms of lines, equations of lines. equations of a line. Okay, number 1, equation of x-axis. Okay, we know that on x-axis y coordinate is 0, and therefore we write y is equal to 0 on x-axis. Y is equal to 0 is the equation of x-axis. Similarly, we can write equation of y-axis. Okay, we know that on y-axis x coordinate is always 0, and therefore we write x is equal to 0. Now x is equal to 0 is the equation of y-axis. Similarly, we have equation of a line parallel to x-axis. Equation of a line parallel to x-axis is given by y is equals to b, and equation of a line parallel to y-axis is given by x is equal to a. Now in the equation of a line parallel to x-axis, y is equal to b is given, where b is y-intercept, clear? And in the next equation of a line parallel to y-axis, x is equal to a is given, where a denotes the x-intercept, clear? Okay, now we have the next form of equation of line, which is called the slope-intercept form. So let us see that. We will derive the formula for that equation. Okay, number 5 is slope-intercept form of line. Okay, it is y is equal to mx plus c, where m is the slope of a line and c is y-intercept. Okay, let us try to understand how this formula is derived. Let us consider or draw x and y axis. Okay, and then we will draw a line which has a point P on it having coordinates x, y. Clear? And let me draw this point at some distance. Okay, so here I take point P having coordinates x, y, and from P, okay, this is x-axis, y-axis, O is the origin, P is a point on the line L. We will draw PM perpendicular to x-axis from point P, and let this point, the intersection of line L and the y-axis, be point Q. Okay, the length in this case we will consider to be C. Okay, obviously OQ is a y-intercept, clear? Intercept made by the line on y-axis is called the y-intercept. So OQ in this case is y-intercept. Again from this point Q we will draw one more perpendicular, QN on PM. Okay, so let us write down the description. Okay, the angle of inclination of line L is theta. So again this angle will also be theta because these both are corresponding angles. So let theta be the angle of inclination of line L. Okay, OQ is equal to C is equal to y-intercept. Clear? We will, okay, let Px, y, let Px, y be a point on line L. Now we will draw PM perpendicular to x-axis and QN perpendicular to PM. Clear? Okay, now QOMN is rectangle, we know, yes or no? So QOMN is a rectangle and therefore MN is equals to OQ, MN is equals to OQ is equal to C, and QN is equal to OM is equal to, what will be the length OM? Obviously the x coordinate of point P, which is x. Okay, clear? Okay, what will be the length PM? That is equal to y coordinate of point P. So PM is y and therefore PN is equals to PM minus MN, and therefore we get PM is equals to y minus C. Clear? Okay, now we can take this triangle QNP. In triangle QNP, we use the formula of tan theta. So tan theta is equals to, formula is perpendicular upon base, so Pn upon Qn. Okay, now tan theta, the slope is represented by symbol m. So m is equals to, Pn is y minus c, okay, and the Qn is x. So y minus c upon x, therefore mx is equals to y minus c, or y is equals to mx plus c. So in this way the formula, the slope intercept form is derived. Okay, remember that in the formula of y is equals to mx plus c, m is the slope of line and c is the y intercept. Clear? So whenever the two values are given, you can directly use this formula to form an equation of required line. Okay, now let us see the next formula. Okay, what happens if the line if the line does not have y intercept? So it may be possible when the line is passing through the origin. Yes or no? I hope you have understood this theorem very well. Okay, derivation, the important thing is you should remember this formula, y is equals to mx plus c. Now what will happen? If the line does not form or make y-intercept, or in other words, suppose if a line is passing through the origin O. Okay, if the line is passing through the origin, in that case the value of y-intercept will be 0, yes or no? So we will note that if the line is passing through the origin, then we have value of y-intercept 0. Okay, c will be equal to 0, and therefore equation of line passing through the origin, passing through the origin will be given by y is equals to mx. Okay, so this is the formula to be used when it is mentioned in the question that the line passes through the origin. You can directly put this formula, y is equals to mx. So only by knowing the value of m, that is the slope, you can form the equation. Clear? Okay, now let us see the next form, that is called the point slope form of a line. point slope form. Okay, point slope form is given by the formula y minus y1 is equal to m into x minus x1. This is called the point slope form. Okay, let us try to understand this one with the help of diagram. Okay, we have x and y coordinate axis. O is the origin and a line L, yes or no, such that a point is given. Suppose we are given a point A having coordinates x1, y1. Clear? On the line. Okay, we will consider one more point P having coordinates x, y on the line. This point is already given and we have taken one more point on the line. Clear? So let us write down. Okay. Okay, again here theta will be the inclination. Let theta be the angle of inclination of line L. Yes or no? A x1, y1 be a point on line L. Okay, we will take let P x, y be a point on line L. Px, y, another point taken on line L. Now we will draw two perpendiculars from point A as well as from point B. Say AM and PN perpendiculars, and then one more perpendicular from A on PM. Okay, Q, AQ. Clear? So let us write down the description. Draw PM and AM and PN perpendicular to x-axis, and we will draw AQ perpendicular to PM. Okay, obviously the length OM will be given by the x coordinate of point A, that is x1. Okay, OM is x1 and ON will be x coordinate of point B, that is x2. So OM is x1 and ON is x2, and therefore MN will be x2 minus x1. So we get MN to be x2 minus x1. Similarly, y coordinate will give you the length AM, y coordinate of point A, that is y1. So this is y1, and therefore opposite side of a rectangle QN will also be y1. Again, length PN will be the y coordinate. Y. Yes or no? Clear? Okay, there is one mistake. Coordinates of point P are x. So this length is given to be x, not x2, and therefore length MN will be x minus x1. Clear? What will be the length MN? That will be x minus x1. Okay, now this is y and QN is y1, and therefore length PQ will be y minus y1. And opposite sides of rectangle are equal. MN and AQ will be equal. Now MN is x minus x1, so AQ will also be x minus x1, and this angle is theta. Clear? So now OM is equal to x1, ON is equal to x, and therefore MN is equal to x minus x1 is equal to AQ only, because opposite sides of rectangle are equal. Again, AM is equals to y1, which is equals to QN. Yes or no? And Pn is equals to y, and therefore PQ is equal to Pn minus Qn, and therefore PQ is equal to y minus y1. Done. Okay, now we will take triangle AQP. So in triangle AQP we will put the formula of tan theta again. Tan theta is equals to PQ upon AQ. Okay, now tan theta is the slope denoted by m, so m is equals to PQ is y minus y1 and AQ is x minus x1, and therefore multiplying m into x minus x1 is equal to y minus y1, or finally we will get the formula to be y minus y1 is equals to m into x minus x1, which is called the point slope form. Clear? Remember that in the formula m is the slope of the line and x1 and y1 are the coordinates of the given point. So when you are given the coordinates of a point and the slope is known, in that case you can use this formula. Okay. So this was the point slope form. Now we will see another form, that is the 2-point form of a line. Okay, now the 2-point form, another form. This was point slope was number 5, 6, now 7, formula number 7. 2-point form of a line. It is given by y minus y1 upon x minus x1 is equals to y2 minus y1 upon x2 minus x1. This formula is called a 2-point formula. Remember that here y2 minus y1 upon x2 minus x1 is the formula to calculate the slope m. Okay, that we saw in the beginning. So here in place of this we can put even m. Yes or no? So it becomes y minus y1 upon x minus x1 is equals to m, or y2 minus y1 upon x2 minus x1. Clear? Okay, now here 2 points will be given. When to use this formula? When the coordinates of the 2 points on a line are given. So here a x1 comma y1 and b x2 comma y2 are 2 points on line L6. Yes or no? Okay, so let m be the slope. Yes or no? Let m be the slope of a line. Okay, let m be the slope of a line. Okay, now we have a formula. Whenever you are given the coordinates of the 2 points, we can calculate the slope m. Therefore slope m is equals to y2 minus y1 upon x2 minus x1. Here this is the slope. number 1. Now line L passes through point A x1 comma y1. Okay, so here we will use the previously derived formula, point slope formula. One point is x1 comma y1 and the slope is m. Okay, and therefore equation of line L will be y minus y1 is equals to m into x minus x1. Clear? This is the formula. Okay, now in this formula we will put the value of m. The value of m is y2 minus y1 upon x2 minus x1. So for m we will substitute 1. So substituting value of m, okay, in equation 2. So substituting value of m in equation 2, we write now y minus y1 is equal to, for m we will put y2 minus y1 upon x2 minus x1 into x minus x1, or taking x minus x1 in the denominator, the formula becomes y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So this is the derivation of the 2-point form. Clear? So whenever you are given the coordinates of both the points, 2 points on a line, you can directly use this formula, where x1 y1 and x2 y2 are the coordinates of the given points. Clear? So these many formulas are there which you have to remember. As far as the class 10 the syllabus is concerned, there are many more formulas, but those formulas you are going to learn in the higher classes. Clear? Okay, so I have explained you all the formulas of various forms of or various formulas of a line. Yes or no? Now we are going to solve the exercise on the basis of this. Okay, before we solve the exercise, we will learn few more things, 2 more topics. Okay, the relation between the slopes of parallel lines and perpendicular lines. Okay, those 2 relations we will see, and then we will start exercise. So let us see the 2 relations. Okay, relation between slopes of two parallel lines, and number 2, two perpendicular lines. Okay, so okay, first we will see the relation between the 2 parallel lines. Okay, so if the 2 lines are parallel, if the 2 lines are parallel, okay, what will happen if the 2 lines are parallel? Obviously the angles of inclination formed with the positive direction of x-axis will be equal. Yes or no? And if the angles are equal, suppose theta 1 and theta 2 are the angles formed by the 2 parallel lines. Let us try to understand this fact like this. Okay, we have 2 parallel lines. Yes or no? So if angles form, this is theta 1, then obviously this is and this is theta 2. Obviously, since the two lines are parallel, these two pairs represent a pair of corresponding angles, and therefore theta 1 will be equal to theta 2. Therefore, tan theta 1 will be equal to tan theta 2, and therefore slope m1 will be equal to slope m2. Clear? If the two lines are parallel, yes or no, then their slopes are equal. Yes or no? If m1 and m2 are the slopes of two parallel lines, then we can write that m1 is equal to m2. So this is the relation for two parallel lines. Now what will happen if the two lines are perpendicular? So let us see the relationship between the two perpendicular lines. Number 2. If the two lines are perpendicular, in that case what will happen? Let us see, let us draw a diagram to understand that. Okay, we have a line, say L1, okay, and another line which is perpendicular to L1. This is line L2. Okay, now these both the lines are perpendicular, 90 degree. Clear? Say the angle of inclination of line L1 is theta 1 and angle of inclination of line L2 is theta 2. Clear? So obviously let us find out the relation between the two angles. Now we know that the two angles, yes or no, this is an exterior angle, okay, and measure of exterior angle is equal to the sum of two interior opposite angles. Clear? So if the two lines are perpendicular, in that case what will happen? That theta 2 will be equal to theta 1 plus 90 degree, yes or no, and therefore tan theta 2 will be equal to tan 90 plus theta 1 we can write, okay, and therefore tan theta 2 will be equal to tan 90 plus theta will be equal to minus cot theta 1 in the second quadrant, and therefore if you take this cot theta 1 can be written as 1 upon tan theta 1, and therefore multiplying tan theta 1 with tan theta 2 we get the relationship that tan theta 1 into tan theta 2 is equals to minus 1, or say tan theta 1 is represented by slope m1 and tan theta 2 is represented by slope m2, then m1 into m2 is equal to minus 1. Clear? If the two lines are perpendicular, then the product of their slopes is equal to minus 1. Then the product of their slopes is equal to minus 1. Okay, so we will remember this relationship, m1 into m2 is equals to minus 1, or m1 is equal to minus 1 upon m2, or m2 is equal to minus 1 upon m1. So in case of two perpendicular lines, if one slope is given, you can easily find out the slope of the other line. Suppose if the slope of one line is 1 by 2, then the slope of a line which is perpendicular to given line will be minus 2, negative reciprocal. You just have to take the negative reciprocal of the given value. Clear? So you will get the slope of the perpendicular line to the given line. Okay, so remember these relations. So we have learned two relations for parallel lines, m1 is equals to m2, and for perpendicular lines m1 into m2 is equal to -1. So far all the explanation which was to be given in this chapter I have already given. So all the explanation is over now, and in the next video we will start the exercise of this chapter. Clear? Thank you very much.